Hello, myself Dr. Bhawna Agrawal, Professor, Mathematics Department, Rabindranath Tagore University, Bhopal. Now come to my next video lecture which will cover gradient, divergent and curl. Vector differential operator delta. We may say as this del. This value of del is I del by del x plus g del by del y and k del by del z. This value operator delta is operate for gradient, divergent and curl. If a function is a scalar, then it is used for gradient, and if a function is vector, then it is used for divergent as well as curl. Gradient of phi. This operator is used for gradient of this scalar function phi. Let us take a scalar function phi x, y, z. Grade phi. For this grade phi using this operator phi, del. Value of del is I del by del z plus j del by del y and k del by del z. Differentiating this phi with respect to x, y and z respectively. What we get? A scalar function. Let us take an example. Find the gradient of this scalar function 3x square y minus y cube z square at this particular point 1, -2 and -1. Grade phi. Use the operator grade. Del. Substitute the value of del I del by del x plus j del by del y and k del by del z, and value of phi from this given problem 3x square y minus y to the power cube and z square. Differentiate this given function one by one with respect to x, y and z. This given function is scalar. On differentiating, what we get? Differentiating this with respect to x, 6x yi. Here x term is not there. Only this term is to be differentiated. In second case, differentiate this scalar with respect to y. What we get? 3x square minus 3y square and z square plus k del by del x. For this will be 2y cube, here minus of z, k. At this particular point 1, -2 and -1. Substitute the value of x, y and z here. What we get? This 12y minus 9j minus 16k. Now what is the conclusion from this? That when we are applying a gradient over a scalar function, what we get? A vector function. Divergent of a vector f bar. This operator del with this vector function, dot product between this because divergent is there. If f is equal to f1i plus f2j plus f3k be a vector function, then div of f, dot product between del and this vector function. See this. As we already know, in case of dot, I have already taught you earlier that I dot I, j dot j and k dot k is 1. That's why differentiating x, we get f1, I dot I is 1. Differentiating with respect to y, j dot j is 1. Differentiating with respect to z, k dot k is 1. What we get? A scalar function. The resultant is that when we are differentiating a vector by applying for the operator div, we get a scalar only. A condition is there for a solenoidal div f should be equal to 0. Curl of a vector function, curl. If curl is there, then cross product between operator and vector function. If f is equal to f1i plus f2j plus f3k, we are taking a function vector, applying curl over there, cross product between del and this vector function. Determinant of this, I, j, k, position is fixed for the first row. From the first bracket, we'll use the coefficient of I, j, k for the second row. From the second bracket, coefficient of I, j, k, that is f1, f2, f3 is fixed for the third row. Simply find the determinant of it. Thus, what we get the result from the curl operator, that if we are differentiating a vector function by applying curl, we get the resultant value as a vector function only. Now a condition is there for irrotational, curl of f should be equal to 0. Unit vector r cap is equal to r vector upon mod of r. Mod of r is scalar only, r. Unit tangent vector del r by del t, mod of del r by del t. Unit normal vector gradient of f is mod of grade of f. Now see, what we have studied in previous 3 slides, that grade f, div f and curl f, for all these 3 we are using this operator. What is the difference between these 3? There is no dot bit for the gradient. For div we are using dot, and for curl we are using cross. This is the basic difference. Dot, cross, and for scalar we are using neither dot nor cross product. Directional derivative is gradient of f dot r cap, where r cap shows the unit vector. Maximum directional derivative mod of grade phi. To find the angle between the two vectors n1 and n2, n1 vector dot n2 vector is equal to mod of n1 mod of n2 cos theta. For orthogonal, n1 dot n2 is always equal to 0, where n1 n2 shows grade of f1 and grade of f2. This is the main formula we usually use for solving the problem. Grade of f of r is equal to differentiation of f dash r and grade r. Some problem related to this operator del. If a problem is given, gradient del of r is equal to n r n minus 1 r cap. You have to prove the left hand side is equal to right hand side. Taking left hand side, that is grade r to the power n. For this grade, use the operator del. Value of this del operator is I del by del x, j del by del y, k del by del z. Differentiating this r to the power n one by one with respect to x, y and z. Differentiation is there. On differentiating r to the power n, what we get the result? N r to the power n minus 1 in all 3 terms. Taking n r to the power n minus 1 common, left portion is I del r by del x plus j del r by del y plus k del r by del z. R is itself a function of x, y, z. R square is equal to x square plus y square plus z square. If we differentiated this, 2r del r is equal to 2x del x. Finally, del r by del x is equal to r by x by r. And del r by del y is equal to y by r. And del r by del z is equal to z by r. Substitute all these 3 values in the previous equation. What we get on substituting? X by r here, y by r and z by r. Taking r common from this, left is xi plus yj plus zk. Value of this xi plus yj plus zk is r vector. Substitute the value here. What we get? N r n minus 2 r vector. Thus we get the right hand side. Now let us take a, b be the differentiable vector function and phi be the differentiable scalar function. Now we are using gradient, divergence and curl. The relation between addition of 2 vector, multiplication with scalar and vector, and cross product between 2 vector and dot product for the gradient. These are some formulas which are used for solving the complicated problems. Div of a plus b, where a and b is a vector differentiable vector function. Div of a plus div of b. Curl a plus b is equal to curl a plus curl b. Scalar and this vector will apply div or curl. Scalar a is equal to gradient of phi, because for scalar we are using gradient, grade phi dot a is a vector, plus scalar div of a. Again, phi and a, phi is a scalar and a is a vector. We can use curl as well as div. Gradient phi dot a plus phi curl a. Next formula is div cross product between these two vector b curl a minus a curl b and curl a cross b is equal to b dot operator a minus b div of a minus a dot delta b plus a div b. And the last problem, which is the dot product between these two vectors for the gradient. This is the formula which we use for the problems. Now come to the next problem. 2 del square f is equal to f double dash plus 2 by r f dash r. We have to prove the left hand side is equal to right hand side. In this case, 2 operator is used. Now for which operator we'll use gradient, divergent or curl? How to identify this? See, left hand side, here f of r is scalar or vector? Yes, it is scalar. So just side by of this operator, we will use gradient for this, because gradient is for scalar function. To grade f of r, leave this operator. This operator what will decide afterwards. To grade f of r, this you already know. Grade of any function r which is a scalar is the differentiation of this f dash r grade r. Substitute the value here, we get this much. Also we know grade r is vector r upon scalar r. Substitute the value, this we get. Here a point is to be noted that what we get, product of scalar and vector. Scalar is f dash r by r. This whole thing is scalar. This is scalar. Take this as phi. And this r vector is, take this as a. Apply the formula div phi a. Why div? Here cross is not there. That's why we are using div for it. And for gradient we are not using, because there is a formula for scalar and vector. Either we may use div or curl. That's why we are taking this operator as div. Apply this formula here. Div of phi dot a plus phi div a. Scalar function and vector. Scalar function phi, value of phi f dash r by r. Div a, div of this vector r plus gradient of this dot r cap. Div of r vector is always equal to 3. Substitute the value here 3. And for gradient, f of r is f dash r grade r. Grade of this scalar function, differentiating this function, del r by del this, and grade of r, this outside r vector as it is. 3 f dash r by r plus del by del r f dash r by r, grade r dot r vector. Now differentiating this f dash by r, we can differentiating by division rule as well as product rule. Here we are applying the product rule. As we know, differentiation of two product is first function differentiation of second plus second function differentiation of first. Now let us see how to differentiate. F dash r, differentiation of f dash r, second function as it is 1 by r plus first function f dash r as it is differentiation of second minus 1 by r square. Differentiation of 1 by r is minus 1 by r square. Grade r dot r cap. 3 f dash r by r as it is. Now take this minus inside, we get this much, and value of grade r is r vector upon scalar r. Because of this we get this much. Now taking r outside, it becomes r square. R square by r square, that is 1. We get the result this. Now taking this one in a bracket plus f double dash r. On solving this we get 2f dash r by r plus f double dash r. Thus is equal to right hand side. Thus today we have studied about the gradient, divergent and curl. For the next video, I'll discuss about the single integration, double integral and triple integral. Thank you all.